Oh, wow.
Fantasy, picture you in me, see you in my dreams. Are you near me? In a fantasy, picture you in me, see you in my dreams. Are you near me? Are you near me? In a fantasy, picture you in me, see you in my dreams. Are you near me? Oh, how I want you now, I just can't wait. Oh, how I want you now, I just can't wait. Oh, how I want you now, I just can't wait. Oh, how I want you now, I just can't wait. Oh, how I want you now, I just can't wait. For your love, for your love. Oh, how I want you now, I just can't wait. For your love, for your love.
What up, everybody? Mic check, mic check. Getting all my, well, no mic here. Looks like no audio. Check, check. All right. So if you guys can let me know in the comments if you can hear me, that'd be great. Okay, looks like Martin says, okay, sound does work. Great. Awesome. So, yeah, brilliant. What up, everybody? I originally scheduled an event that it doesn't look like OBS started on the event as it should have. It just started a whole new live stream. So I'll give everyone that was waiting in the live stream page a minute to pop in here before I get started. And clearly I do need to do a little bit more training on OBS because I am a little bit lost here. I'm trying to use the different scenes and it doesn't seem to want to populate as what's actually streaming. So anyway, at least it's somewhat functioning properly. It looks like it's sharing my screen and I don't have to worry about people snagging the link, I hope. So we'll see how that goes. But yeah, so what up, everybody? Happy Friday for yous. Just wanted to go over some stuff with Eclipses because there's just so much wrong with Eclipses, and dang, I wish I could kill the webcam. Like, I don't know how to do that. Like, I'm sure it's in the way now. Huh. I guess I could unplug the damn thing. Yeah, not very helpful so far. So sorry, everyone. This is the first time I've used OBS in a live stream, and I suppose I should have done a private stream just to practice, but I didn't think it would throw me off so much. But not a big deal. We'll still just charge through with what I was going to talk about anyway, and hopefully my big head won't get in the way too much. So, but I will. Yeah, it says it's muted, unmuted. I don't know how to get it from the preview panel to the actual transition panel, but anyway, figure it out later. So hopefully, if you guys can see basically the majority of this drawing diagram, I'll put it up towards the that side of the screen, so hopefully I'm not in the way, but hopefully y'all can see it good. So let me just check the comments and see if that is actually the case. And if there's any audio sync issues, or like, just let me know in the comments and I'll try to remember to pop back and forth in there every now and then. Okay, so actually I can see the delayed screenshot, so yeah, okay. So I'll just get right started with it. There's just so many different things wrong with eclipses. It's ridiculous, and I think one of the biggest things to get out of the way first is the scale of the alleged heliocentric model, because the scale of the model is very difficult to get comprehensive look at lots of different bodies to scale. So like the sun, the moon, and the earth to scale is almost impossible to get on a single slide without some of the objects being too small to see. Or if you make them so that, like this one here, where the earth can be seen very small, then to scale the moon is even then a very small dot, and it's like 30 earth distances away. So this image here is pretty much to scale for the earth and the moon in terms of the alleged sizes and distances in the ball earth model. And so, and if you were to try to place the sun on a diagram to this scale, it would be like several doors down. It'd be like millions, probably more than several doors. It'd probably be like states away. It'd be very distant. So it'd be like hundreds of millions of times the distance that you see here, right? So just mind-boggling distance. But when you're thinking about things like eclipses in this model, you sort of have to keep these scales in mind, because like if I'm going to draw a diagram like this where you've got the sun, the moon, and the earth in the same slide, I mean clearly you're never going to be able to do that to scale unless you make the sun and the earth and the moon like microscopic, and they'd be so distant away. I mean it's very, very hard to get on a single slide. So you know, suffice to say that these diagrams aren't to scale. But basically what we got here in terms of, we'll talk about solar eclipses first, is we'll think of it in 3 dimensions, but in order to do so, you sort of got to look at it from 2 different sets of 2 dimensions, right? So for this first slide, we're looking like basically we're sitting in the ecliptic plane and looking at a cross section of the sun, moon, and earth during a solar eclipse, not to scale, but like I guess you could say a side view. And then in the next slide, you've got basically a top-down view, okay? And really, you can do this in 2 dimensions. It doesn't have to be in 3 dimensions, because in order to get a solar eclipse in the heliocentric model, you have to have this alignment between the sun, moon, and earth on the ecliptic plane. So like if we're looking at a side view, the moon is alleged on its orbital path to diverge from the ecliptic at a maximum of 5 degrees. So if I get this damn thing to turn, so sometimes, you know, according to the standard theory, sometimes the moon is going to be like, you know, orbiting that way. It'll be north of the ecliptic plane, and other times it'll be, you know, continue that line out south of the ecliptic plane. But in order to get an eclipse, you have to have that alignment on the ecliptic plane. So it's sufficient even really to look at a solar eclipse in a top-down view only, because you know that there must necessarily, in the ball earth theory model, there must necessarily be this alignment right directly on the ecliptic plane. So it doesn't really matter what the moon's orbital divergence from the ecliptic plane is. Sometimes we know that at least in this model, it has to be aligned to the ecliptic plane during a no moon phase to get the solar eclipse. And so, like, you know, everybody will, all the ball earthers try to say it's more complicated than you can understand, and that you've got 3 dimensions working. But again, really, for an eclipse, at least for a solar eclipse, you don't have to get too 3-dimensional into it, because you do have that alignment allegedly on the ecliptic plane. And so, with all that in mind, and with this scale in mind, so the moon is, you know, this little diagram here is to scale. It's a very tiny object, very far away from the Earth. But what they say is going on is summed up nicely here from a side view, and it's summed up nicely here from a top-down view. Right. So basically, the first issue that I want to talk about with solar eclipses is the apparent or not the apparent, but the actual angular size of the moon's shadow. Okay, because in an eclipse, when you've got this condition here in the ball Earth model, where the moon is transiting the exact point in space where the apparent sun is, it's casting a shadow on the Earth. And you know, there is pretty good evidence that supports the notion that during a solar eclipse, it is in fact the moon that's apparently transiting the sun. Because again, solar eclipses only ever happen during the no moon phase, which is exactly what you'd expect if the moon's phases were a result of the reflection of sunlight and the relative positions between the sun and the moon. In reality, we're not even talking about the ball Earth model, and so it makes a lot of sense that it is actually the moon transiting the sun, and whatever's casting that shadow during a solar eclipse, and I would argue that it is probably the moon, but whatever it is, that shadow is usually 50, 60, 70 miles in diameter, and sometimes is much, much smaller. There's like a handful of occasions where the moon's shadow, or the totality of the moon during a solar eclipse, has been like 2 or 3 miles in diameter. And so that the whole problem with this scale here, sorry if you guys can't see it, I keep forgetting that. But with this scale here, to think that this little tiny object, the moon, is going to cast a shadow hundreds of thousands of miles through space, and that shadow is going to hit the Earth, and the angular size of that shadow being anything but at least the diameter of the moon, doesn't make a lot of sense in the heliocentric model. Because in reality, especially if you're dealing with a single light source and a single obstructing object that is a sphere, you can't demonstrate shadows increasing in angular size with distance from the obstruction. It just doesn't. Reality, light and shadows don't work like that. And so only in this theory do shadows work like that. And it is a big problem because, especially when you're talking about these distances, the angular size, or the actual size of the moon's shadow, should be at least as wide as the moon, if not much wider. And that's explained away by the umbra penumbra excuse. It's basically apologetics for the ball Earth model. However, that all of the claims involved with the umbra penumbra nonsense totally contradict what Eratosthenes necessitates for his values to be correct. So like the whole Eratosthenes experiment hinges on the light from the sun traveling at nearly perfectly parallel to one another at the point where it's hitting the Earth, and at the point where roughly when it's hitting the moon as well. So you sort of can't have both of these. You can't have the light hitting the Earth or hitting the moon at a huge convergence, or at a steep convergence, to create these sort of conical, stylus-like pinpointer little tiny shadows in the ball Earth model. That sort of thing just doesn't work. You can't replicate that. Anytime you're dealing with light and shadows in a single light source, a shadow is always going to get larger in angular size proportionally with distance from the obstruction, or at least if you play around with the distance to the light source, as well as the distance to whatever wall the shadow is casting on. If you play around with those distances, you can get it to where the angular size of the ball object is going to remain the same angular size, but certainly not diminishing in angular size off into a point at some distance away. That's absurd, and yet you have to have that sort of thing going on. To these scales right here, where that's the moon and that's the Earth, that sort of thing has to be going on in order for the ball Earth theory to work. So this is just one of the big, huge problems with the heliocentric theory, and where physical reality, observable, testable physical reality, does not jive with theoretical physics and theoretical astronomical values. And really, there's very seldom instances in reality where what's going on in the heavens can actually be tangibly measured and tested here on the ground in reality. Very few. And I would say that one of those very few things, the moon's shadow, is just huge evidence against the ball Earth theory. There's no other sort of astronomical instances where we get the luxury of an actual shadow of an object. And so this is a big, huge problem for the Ball Earth model, astronomically speaking. And so, of course, they have to invent these wild theories about the umbra and penumbra situation, where basically what they say is that the light from the sun is converging with itself at some point prior to hitting the moon, and then at that point it is then a divergent light source, and you get this nice mathematical, geometrical, theoretical effect where you also get sort of the inverted angle of that geometrical source, convergent source, from the moon. So you get this nice theoretical stylus pointer of a shadow from the moon in theory. But if you try to demonstrate how that actually works in reality, there is no experimental or physical evidence for it. And in fact, the little bit of physical experimental evidence we have in terms of the shadow of the moon completely contradicts the heliocentric values. Now, here's sort of another thing while I've got this slide up, just saying on solar eclipses, that I think is a much bigger problem than the heliocentric team will ever admit that it is. And that's one of their most effective tactics, is when you find glaring problems with their model, they basically use the argument that you don't understand their model and ignore the problem that you're pointing to, pull some, dictionary term out of a hat that, has been constructed to explain away this real phenomenon, and they consider that as good enough. But in fact, all they're doing is blindly apologizing for their belief system and refusing to look at evidence that contradicts their belief system. So this is the problem as I see it, and maybe I'm wrong. I'm just postulating something here, but I have thought about it extensively. I've diagrammed it out lots of times, and I can't get around this one other point that I haven't really mentioned much, just because I know how the globe earthers like to argue against this sort of thing. And their argument usually entails ad hominem attacks and saying I don't understand their model. But at any rate, so the issue I have is during a solar eclipse especially, there's one singular point in space, really, that the moon must traverse in order to achieve that total solar eclipse. And where that point is must necessarily be directly in line with the ecliptic plane on a side level as well as a top-down level. So where the sun appears to be in the sky is always going to be representative of the ecliptic plane no matter what. Okay, and so looking at this on the macro level from the side view, we see exactly where the moon has to be in order to get the eclipse. Okay, and the same thing really goes for the top-down view. Okay, because again, if the moon is in its orbit and it happens to be south of the ecliptic plane or north of the ecliptic plane, you don't get the eclipse. And similarly, once it's traversing, it has to be in the no moon phase in order to really hit the sun dead on balls accurately. So what this is, basically in a 3D environment, you've got a crosshairs of sorts. You've got the top down, you're looking at a single point where the moon must be to get the eclipse, and from the side view you also have a single point where the moon must be to get the eclipse. And how does that translate to the Earth? Well, it's very simple actually. It should be on the point of the Earth, whatever meridian line happens to be experiencing direct exact high noon, and whether their clock says high noon or not, it's exactly when the sun is 90 degrees overhead. Exactly on that meridian line, high noon, and from the other way, it has to be directly in line with the ecliptic plane. Okay, so translating that to Earth, it would mean eclipses, shadows, should really only be cast on a very specific point on the Earth. Now, depending on what season it is, we're talking about axial tilt here, you're going to get a range of where that shadow is going to hit in terms of meridianally. It's going to range in between basically the tropics. So that shadow must necessarily, in the Ball Earth model at least, must necessarily be confined to somewhere in between the tropics, depending on the time of year. But it would be, it would be depending on really the season. So it's not going to it could vary over time between eclipses, but for a single eclipse, when you're looking at that event signature, and maybe I should pull up an example of an eclipse signature so you can get an idea. But the problem that I have is that eclipses don't actually occur exactly at the high noon point as you would necessarily expect from the top-down sort of view, as well as from the side view. So, for example, on this view, there's eclipse signatures, and I can try to find them and pull them up, but they're there, I promise. There's eclipse signatures where the totality of the eclipse, this shadow that must necessarily be somewhere equatorial, so like if it's the equinox, it would be at the equator, and if it's the northern summer, it would be at the Tropic of Cancer, and if it's at the southern summer, it would be the Tropic of Capricorn. Or maybe a little bit south or north of those points, but not by much, right? Just a couple degrees. The point is, though, there's eclipse signatures in history, and you can pull these up, that the totality of the moon actually traverses the poles, either the north and south poles, in different events, obviously. And so this is one big, huge problem, the fact that you're somehow getting this specific pinpointer condition that must necessarily be pointed at the high noon mark on Earth and must necessarily be pointed at somewhere in between the tropical area, because it's a very well-defined crosshairs that we've got here on where that shadow should be, and yet for some reason we're seeing it up traversing the poles. And of course, if you look at the timeline of eclipses, they start happening sometimes at 8 in the morning, and they travel across the United States, for example, and that time, accounting for time zones, we'll use Greenwich Mean Time. It's happening at all sorts of different times, and certainly not exact solar high noon as you would necessarily get to meet these specific conditions in the ball Earth theory. And so, this is yet another huge problem with the ball Earth theory, that once you understand it, it totally refutes the whole heliocentric theory. So let's just look at eclipse signature diagrams, so you can see what I mean. And I think maybe I should go to the Facebook page, $5,000 NASA Eclipse Challenge, because my friend Brian did a bunch of really great research and documented all that stuff. And part of that is all of these charts that show eclipse signatures. So hopefully I won't have to dig around too much to find these for you guys, but it's pretty crazy when you think about it, because you would think that astronomers and theoretical physicists sort of people would have figured out like all these glaring inconsistencies between reality and what you would expect in the ball Earth theory. And it just goes to show you that science is not being objective. Science is not trying to think outside of the box or disprove conventional agreed upon theories, which they should be doing, but instead, at least in the theoretical departments of science, they're merely adhering to dogmas and regurgitating things that they've been told. But when you go to actually try to verify these things, that's a whole horse of a different color. So yeah, here's a good example of these eclipse signatures. Each one of these squiggly sort of lines is a different event, but there's a couple of them where you can see the totality of the eclipse signature literally traverses the poles in a couple of examples. And when you stack that up against what we should see in the ball Earth theory, it's quite impossible. It really is quite impossible. Like, in what set of conditions, like, how could you possibly get a shadow of the moon, even if you're saying that it's because of axial tilt and it has to do with, during the southern summer in this example, how can you get a shadow of the moon from the sun, on the bottom of this ball, right? It is just absolutely ridiculous. But that's observable reality. I mean, we had a pretty great eclipse in 2017 that went clear across America, and the times for that thing range. I think it started hitting the West Coast at like 8:30 in the morning or something, and progressively it got to be around noon or so when it was visible over on the East Coast, something like that. And the idea that the this sort of stylus pointer of the Earth, of the Sun, Moon, Earth alignment upon the ecliptic plane necessarily is doing anything but pointing directly at this point right here. So it can't be pointing down here and casting a shadow over here. It has to be at this point right here, you know. So I'm just not sure how astronomy missed all of this over the years, but in their defense, the heliocentric model has changed drastically in its values over the centuries, and so certain things that may have made sense to a particular astronomer 500 years ago or 400 years ago would be considered ridiculous in modern terms, or even in terms of an astronomer that was 200 years after that one, or 200 years before, for that matter. But okay, so moving right along with eclipses and the issues with them, we'll go to lunar eclipses now, because there are some big problems with lunar eclipses as well. The first thing, and again, not to scale diagram, and we are just merely humoring the ball Earth theory, lunar eclipses have some big problems because, again, you must have this exact alignment upon the ecliptic plane. Full moon is a necessary condition for lunar eclipses, so in that regard, the ball Earth theory does make some sense. However, just because a lie solves more than one hypothetical issue doesn't make it true. Although the heliocentric model really does love those lies that sort of fit the criteria of more than one application, because it does give it the illusion of truth, when in reality, you know, it's just a very convenient and well-crafted lie. And so that, like lunar eclipses, is no exception to that sort of heliocentric bias and confirmation bias, rather. So okay, so the big problem that I see right off the bat is the frequency of lunar eclipses, because again, going back to the whole thing with light and shadow, in reality, if you assume the ball Earth model, you would think that the Earth's shadow would be at least 8,000 miles in diameter, and possibly much larger than 8,000 miles in diameter by the time it reaches the moon at this scale. But instead, what they say happens is that the Earth's shadow is a very tiny sort of pinpointer, and I guess I'll draw this in real quick, sort of tiny little pinpointer that nicely fits the size of the moon angularly by the time it reaches that point. And I don't get how people don't see how wrong this is, but bear with me one second. Let me... No, I can't walk and chew gum at the same time. I'm kidding. Right. So what they say is going on, and I'm not sure why this thing is two colors. I'll just make it one color. Is that the shadow of the Earth coming from the sun? The Earth is casting a shadow that diminishes in angular size as it gets to the moon. And so the fact that over a 100-year period, so if you go from 1900 to 2000, a 100-year period, there's roughly the same number of solar and lunar eclipses. And again, if you hand them the penumbra umbra garbage, then that does make some sense, because in order to get a lunar eclipse, then the moon must traverse this very tiny single point in space, much like it must do in order to traverse the sun. And so by that logic, it does kind of make sense that we see an equal number of lunar and solar eclipses over 100 years. However, when you apply reality to this equation and apply how light and shadows actually behave in reality, you would sort of expect to see a larger target area, the shadow of the Earth, to be a larger cross-section in space than the Earth, or at least as wide as the Earth. And so, you know, you would expect to see lunar eclipses at any point while the moon is in the full moon condition and somewhat aligned to the ecliptic plane. Because according to the heliocentric model, the moon's orbit places it 5 degrees offset from the ecliptic plane. So sometimes it's north of the Earth's cross-section relative to the ecliptic plane, and sometimes it's south of that cross section. But in between, the majority of the time, really, at least half of the time, the moon should be aligned to the Earth's cross section on the ecliptic plane, with room to spare on either side, because the angular size of the Earth is larger than the moon by it's 4,000 mile radius of the Earth and a 2,000 mile diameter of the moon. So it's a larger area in space, or it should be. But no, of course, we get this magical, non-demonstrable behavior of light and shadow, but only theoretically for the ballers, where the moon must traverse a single tiny point in space to get a lunar eclipse, just as it must do in order to get a solar eclipse. So, you know, I don't understand how people can't see these sort of problems and not agree that there's issue with it. So, and with the moon, the other big problem now is the direction of the shadow, how it approaches the totality of the eclipse. So we're talking like, let me pull up this diagram here. Right, so this little time-lapse image, maybe I should make it larger for y'all, although my big head will get in the way. I'm sorry, I'm going to figure out how to fix that on another one. Oh, I don't want to copy the link location, the image. Right, so for the selenelion, we can see this is going out towards the totality of the event. The so-called shadow of the Earth is transiting the moon from the top down. So, like, how does that work in this scenario where the moon is, in order to get that, so we're looking at a side view. Right now we're sitting in the ecliptic plane looking at the side cross view of the Earth and the moon within the ecliptic plane, and I'll put a little tilt here so you know what I mean. Right, so there's your axial tilt, just so you know what I'm trying to show you. The moon is, in order to get this shadow hitting the moon from the top towards the bottom, the moon would have to be coming up from below the ecliptic plane in order to get that effect where the shadow hits the top of the Earth shadow hits the top of the moon first. But that's not what they claim is happening. They claim that the moon is traveling along this plane here, indicated by the red dotted line. That's the ecliptic plane. So again, we're looking at a side view, and it doesn't, the ball Earth model doesn't explain this. And furthermore, when we're talking about the selenelion, which is an image, which is what we have here in this image, if you were to turn around in this image, like if you had a panoramic view, the sun is up. So during a selenelion, it's a total lunar eclipse where the sun and the moon can be seen in the sky throughout the whole thing. And geometrically, it introduces big, huge sort of physical problems with the ball Earth theory. And just like every other problem that comes along with the ball Earth theory, they make up crap to fix it. So you have all of these weird, bizarre inversions and diversions of light and shadow to get this effect in their model. And the reality of the thing is that solar eclipses are a local event, so it's not visible from everywhere on this side of the ball as you would expect. It's only visible in localized environments. And same thing with solar eclipses. You only get solar eclipses visibility from local areas. And, frankly, the totality of the eclipse, solar eclipse, should be, the signature shadow should be a very good indicator right there on this spot. However, that the moon traversing the sun on these scales here should be visible from anywhere on the ball. So, it's just big physical problems with the ball Earth theory in regards to eclipses, and yet, all we get is basically ad hominem attacks, people saying we don't understand this stuff, and just pulling garbage theories out of their asses, excuse the French, in order to hypothetically solve these problems, or at least apologize for them, without really getting to the root of the issue and addressing it. And isn't that just so very typical when it comes to pretty much everything with the ball Earth theory? Right, so let me check in on the comments and make sure I haven't been talking to myself here for the last good knows how long. But, oh wow, thanks, Earth is seriously flat. I got a $2 super chat. Thank you, man, I appreciate that. Awesome. Um, wow, so wrong live stream. Oh, and he did it in the wrong live stream a while ago. So wow, okay, my bad. Right, so it looks like everybody is still on, and the screen sharing thing is still working. So wow, OBS seems to have worked. I am very happy with that, although I do apologize for the technical stuff at the beginning. Uh, I guess I will get better at this sort of thing with age. So, with that, I'm just going to wrap this one up. Wanted to make it a quickie. Really, it was a test of OBS, and hopefully you guys enjoyed it. One love to all y'all, and I will see you in the next one. Peace out, everybody.